All right, and welcome back to Keynoteworthy, the recurring series where we try to recap all of the exciting launches and things that you may have missed if you didn't get to see the very many keynotes that we'll be having throughout reInvent. Some familiar faces on screen here, myself and Rob Zhu here, co-host for Keynoteworthy, but joined by a very, very special guest, Jeff Barr. Thank you so much for taking some time today to talk to us a little bit about the machine learning keynote.
Happy to be here. Thanks for having me.
Jeff, the one, the only, who needs no introduction. Thank you so much. This is awesome. I can't wait to dive into all the announcements and the features we covered today in the keynote with you. But maybe you want to start us off with some, what was your general impressions? What were some of your high-level takeaways from Swami's keynote today?
I really enjoyed watching the keynote because it wasn't the least bit theoretical. When you think about AI and ML, there's this incredibly deep theoretical basis for the neural networks and the machine learning and the training and so forth. That's all wonderful and a certainly necessary basis. But effectively, everything Swami talked about were real customers solving problems with real services. And when you hear about this incredible range of customers, Domino's and Roche and Cabbage and Nike and BMW and Formula One, these just really cool customers. And they're not dipping their toes in the water. They're not doing some kind of little fringy kind of thing. They're saying this is like a way to really take all this awesome data we have and then build some cool models and then actually get real value from it, deliver better value to our customers, and actually do something. So I was very encouraged by how grounded in reality that whole keynote was.
Yeah, exactly. And lest we forget, you're a first for many reasons, but this is the first year we actually have a dedicated machine learning keynote, which is exciting unto itself. Throughout a lot of the topics that Swami covered, we saw a handful of those launches mentioned in Andy's keynote earlier last week. But before we dive into any of the launches that we saw or the broad themes that Swami covered, as someone who's been following the machine learning story at AWS as a customer and then now here working at AWS, I think I want to frame this in a way that makes a lot of sense to me. And it's, when we think back to launches like Sagemaker a few years ago, we think about last year's launches in Studio and some of the fleshing that out. I see that this like middle stack of opinionated, software that helps developers and companies cut out the cruft or the infrastructure challenges and get straight to delivering value, just like you said, Jeff, was delivered even deeper this year with a lot of launches that make end-to-end pipelines really, really easy. But I'm probably jumping the gun a bit. I think we should probably talk about, some of the stats and numbers that we saw very early on. As Jeff, as you said, there were a lot of stories where customers are using AI and ML on AWS in very tangible ways. And I believe we saw quite a few logos up there. I don't think there was room to fit 100,000 of them, but the 100,000 plus customers using AWS for ML was certainly a salient stat that stood out to me. But we also see the return of this, recurring hierarchy of these services, right? The 3-tier AWS ML stack. Rob, I know you and I speak a lot about this one. This seems like a little bit more of the same here. And again, maybe it's just the first time we're seeing it broken out in a dedicated ML keynote. But what were your impressions there?
Yeah, I mean, just for a quick refresher for all of you, at AWS, we think about AI and ML in 3 tiers. At the lowest tier, what we want to do is provide the infrastructure and machine images for all of the frameworks and the tools for those experts who really just want the raw compute resources. And there you can see us kind of offering the same level of compute customization that we see across the board, right? These are instances that can either be supercharged with the latest GPUs, instances that have up to 400 gigabit per second networking. I will never get tired of saying that. That is incredible, okay? But the thing is, like, we like to say that we have the broadest and deepest set of tools, and machine learning is one of these areas where you really need them, right? If you're operating at that level where you need infrastructure, resources, having the right sized instance is the difference. It can easily make a difference between 50% in your costs for training your models, for making predictions in production. That's why we have so many different kinds of compute resources that are optimized for training. And we'll talk about this later because I think Swami had a really good deep dive into some of this stuff. But popping up one level in the abstraction, we have Amazon SageMaker, which is our end-to-end machine learning tool chain. And there's just so much to unpack here. I'm not even going to try to do this justice in a summary, but we're going to be talking a lot about SageMaker and all the new features we added further on in the recap. And then at the very top of the hierarchy, we have AI services. These are turnkey services that do not require any sort of machine learning expertise. Things like Lex, Poly, Transcribe. These services are ready to go. They have powerful models that can make predictions immediately. So that's really kind of been our strategy from the beginning for how we approach AI and ML. And it's really good to see this keynote highlight the advances in all three tiers.
Exactly. And one other thing I wanted to touch on, and Jeff, I'm explicitly curious in your thoughts here. Swami mentions this rapid pace of innovation here, especially with respect to AI and ML services. He showed a graph at a certain point that had the number of features and service launches in a given year. And sort of at the two poles there, we have this year, which is 250 plus feature launches in the last year. But that is extremely important when we contrast that to 2016, where there were 3 launches, and those were the announcements for Amazon Poly, Lex, and Recognition. I know you write a lot of you work closely with the launch teams, you author a lot of the blogs. What has it felt like to be around and watch this rapid expansion of AI and ML service support here at AWS?
So Nick, great question. And it's pretty cool just to watch the future unfold in effectively real time. It was only 2017 when we launched SageMaker, and it was like, okay, here's this great tool for building and training and testing and deploying your models. And people were like, yeah, that's great. And then the awesome thing that we always do at AWS is we launch these initial offerings, and then we just start listening, and we start getting all these amazing requests from our customers for can it do this? And we think this would be an awesome way to move it forward. And here's a great idea for a new feature. And they were able to connect with our customers and listen to them and learn from them, and then turn all those things into all this massive list of features. They're not just features for the sake of features. These are the things that customers are asking us to do, and really, to me, just show how the customers get to shape the future of these offerings. To me, I think of these services often as almost a fractal surface, where the first go round, there's just a brand new service, and it's just there. And then customers say, well, this and this and this. So a couple more like iterations of that fractal, and you get some more surface area on it. And then you iterate even further, and then the service itself seems to spin off additional services. And you can go just incredibly deep simply by focusing on SageMaker. We started in the number of add-ons we've given, and these are not just random outpourings of an R&D lab. These are the things that our customers are saying we really believe in. We're using these services, and these are our ways we can get even better value from them and do even more with them.
Yeah, exactly. And if I had to take a stab at categorizing, I think some of the biggest blockers to introducing or implementing AI and machine learning en masse, it's just the existence of a large number of unique challenges, whether it is the expertise, whether it is in machine learning, in infrastructure, in GPUs. I guess you could consider those a subset of infrastructure, right? But there's a lot of unique challenges and blockers. And so I think Swami's sort of thesis here around being able to give customers the freedom to invent makes a lot of sense, because whether you are a large enterprise with a mature AI ML stack that wants to spend more time tuning your models, or you're a small company or experimenting with AI ML, just trying to get your first model out the door, the ability to feel free to focus on the features that matter to your customer and those models is what you want to spend your time doing. I know Swami mentioned a few different tenets or ways in which AWS delivers on that promise to customers. But I don't want to monopolize all the time. Rob, I know you had some thoughts about the first one.
Yeah, well, I mean, I feel like this was an interesting segment, because in a way, the freedom to invent and the tenets that Swami covered were almost like a extension or a deeper dive into the will to reinvent that from Andy's keynote from week 1, right? Andy had covered 8 principles for what it takes to build a culture of reinvention. And in a way, I think Swami kind of honed in on a corner of that, where it was specifically what are the bottlenecks to reinvention, to freedom to invent here, right? And I like the direction that he took it because, Jeff, to your point, he kind of made these things really concrete. And this first one kind of focused on infrastructure. Jeff, do you want to take us into this in a little bit of detail?
Sure, and this to me gets back to my roots and thinking back to the early days of AWS, where the big deal was always a brand new instance type. And to me, something awesome is that instances are still exciting, and there's still massive amounts of development happening in this many years after the launch of EC2. Things like the P4D that's just packed with multiple NVIDIA GPUs, as you mentioned earlier, that the 400 gigabit per second networking, which is just incredible. And the idea that you can take a whole bunch of these P4Ds and cluster them. You can distribute your model across them for training or for inferencing. We talked about the fact that the Habana Gaudi, which is Intel's next offering for deep learning training, that's coming next year. And the fact that we have this such an understanding of what it takes to do both training and inferencing. We've already built the Inf1 chip to do inferencing as efficiently as possible, and we announced the Trainium chip, which is another custom AWS design chip that's going to help our customers to train even faster and more efficiently. Now, I think it's really important to point out that when we talk about faster, there's so much data involved here, and there's so many steps that each time we can make any of those some percentage-wise more efficient, we're letting our customers go from here's raw data to here's actually worthwhile, valuable production quality inferences. We're making that faster so they can, it's not just time to market, which is important, it's number of iterations you can do, let's say within the course of a week. The more iterations you can do, the higher quality your models are going to be, the better results you're going to be able to deliver. So all of this effort we put into instances and better networking and better IO and faster and more high capacity databases, all those are directly powering what we're doing here with machine learning ultimately.
Yeah, absolutely. And like you said, it's not just faster, it's also cheaper, right? If you look at the Graviton 2, we see 40% cost savings for the same unit of performance. And this is happening across the board. You mentioned the Inf1 chip, for example. We know for a fact that Alexa devices are now powered by Inf1 chips to a great extent. And the majority costs of end-to-end machine learning workflow come from making predictions, not necessarily from training when you reach a certain scale, right? But I mean, that kind of makes me also, it's encouraging to think about what this does for practitioners that are operating at the lower levels of abstraction, where they're using these frameworks like TensorFlow, MXNet, and PyTorch day in and day out. Nick, I know you've spent a lot of time in this area. What jumped out at you with our announcements in this area?
Yeah, I have one that plugs in well here, but before I get into that, I wanted to talk a bit about, part of speed is not just the speed in which your training occurs through, some sort of configuration on an instance, right? Like obviously faster and cheaper is always better, but using tools that feel good in the hands, or in this case, feel good in the hands of your developers is critical. It is much quicker to write code in a framework that you enjoy, whether that be TensorFlow, MXNet, PyTorch, than it is to sort of have to shoehorn or learn an additional framework simply to do the job that you want to do. And that choice in frameworks is really important because of their sort of high priority of integration with Sagemaker. So in order to get value out of Sagemaker and the suite of products that come along with it, you can use your favorite frameworks. And that ties me into one of my favorite launches here, which is faster distributed training on Sagemaker. I believe this was the first net new launch that Swami mentioned. And essentially what that does is it's a lot of optimization under the hood here. Again, Sagemaker completely abstracting away provisioning of instances, distributing your data, and doing some of those map reduce operations while you're training. This now promising up to 40% faster through data and model parallelism. Swami talked a little bit more about sort of how this works, but essentially it's just further optimizations that significantly reduce training times. There were some numbers around benchmarks for Mask RCNN and T53B, but the point is, there wasn't simply one framework up there. We saw TensorFlow, we saw PyTorch, we see, distributed training coming to meet developers where there are the frameworks that they want. And so when we talk about foundations, it's just as important to have bedrock infrastructure as it is to have tools that feel good in the hands.
Yeah, Absolutely. I couldn't agree more. I mean, this is when I think about what we're trying to do with SageMaker, it really feels like machine learning as it stands today and in the recent years has been speed bump after speed bump after speed bump for big organizations trying to take these workloads into production. And what's really cool is how SageMaker has kind of taken that entire workflow and laid it out end to end, right? I mean, starting from data preparation, and I definitely want to hear you both talk about Data Wrangler shortly. But starting from data preparation and sanitization to, like you mentioned, Nick, dev environment setup, to training and tuning, to deploying these models, to monitoring model drift once the model is in production, to scaling them, to managing. There's just so much to do. And nobody has built a tool, and nobody has understood the problem in this depth until now, which is what makes this so exciting to see, and what makes all these this is kind of the framework. I mean, when we hear about these announcements, really, sometimes you might wonder, okay, well, there's this thing and then there's that thing, but this is really the framework that's operating behind the scenes. This is the scaffolding on which all these features and services hang off of. Is if you think about the end-to-end life cycle for machine learning workflows, there's so many speed bumps. How can we remove them and make customers move faster at scale, safely, securely? But yeah, I think also what that, I don't want to paint the picture where we're just talking about these are benefits that are available today, and customers have been using SageMaker to realize some of these benefits already, and we have a lot of really awesome customer stories that we covered in the keynote today. Jeff, do you want to take us through some of those?
Sure. There are almost too many to mention, but let me do what I can. I mean, Swami talked about Lyft, how they reduced their training time from days to hours. Vanguard deploying their workloads 20 times faster. ADP reducing deployment times from 2 weeks to a day. iFood decreasing the distance traveled for their food deliveries by 12%. These are stunning numbers. And you think about when you're in a mature business, how valuable it is to get 5, 10, 15, 25% better value that you can optimize, continue to optimize what you might have thought was almost a steady state kind of business. It's amazing that you can actually do that. Now, I'm not the world's best football fan, but I do actually love when a weekend game is on the background and I suddenly hear powered by AWS. That always makes my ears perk up, regardless of what I'm doing. I love to hear Jennifer from NFL talk about the player health. I think that's super important. The fact that they are really focusing on health and safety, and that in addition to powering the next gen stats, she showed these really cool, almost a little bit scary kind of physical models of helmets and brains, and seeing exactly what happens when they impact each other with a lot of mass at high speed. You think about the physics there, and it's a little bit gruesome. As a parent, you're like, oh, gee, that's not what I would necessarily want my children to be up to. But seeing how they're using computer vision and doing all of this actual testing of the helmets, and to figure out what are the safest ways to play, and how do we set the rules, and what are the safest kinds of helmets, and to make sure that these players actually are as safe as possible. There's a great human interest side to that of, okay, yes, we have entertainment, but entertainment that leaves the participants with concussions, I don't think that's a reasonable thing to do. So it's great to see that we're able to help them out to power that effort and to support it in a way that is beneficial for everyone.
Certainly. And, when I heard that story, I think on the tail end of it, we saw a very sort of, clear equation here. And that was the combination of NFL's data that they're able to, collect due to, monitoring of the players and all of the stats and telemetry along with that, coupled with the AWS infrastructure that makes it possible to, deploy models that can achieve this sort of scale or do so in such a quick manner. And I think that, this combination of companies have data they want to unlock value from, and that's why they're exploring AI initiatives with platforms just like AWS and all of the services we're going to be talking about today, is one that is recurring. And so I want to talk a little bit more about some of the services in the SageMaker layer that that were announced that make this even more possible. So really quickly, I covered Data Wrangler and Feature Store, which Andy talked about earlier last week. And then I want to get into SageMaker Clarify, because that one was new in today's keynote, and a lot to mention there. So first of which, Data Wrangler is a solution to a very, very poignant problem. If you talk to folks that deal with data, whether they're a data scientist, a machine learning engineer, a research scientist, any class of machine learning practitioner, let's call them, they will probably tell you that they spend the most of their clock time working on cleaning data, and it never feels good. Everyone says this sort of begrudgingly because you don't feel like you get data out of you don't get value out of making your data look the way you want. You get value out of training and deploying the model. And so Data Wrangler is this pointed solution that, without writing any code, enables you to more easily clean and transport your data, spot inconsistencies, basically get past a lot of the gotchas that, essentially are not value driven, but act as roadblocks. So very exciting there. And then next up, once you have your data cleaned and you can transport it somewhat easily, we see Sagemaker Feature Store. So let's say you are at an organization, you have data in multiple different places, or maybe you have multiple machine learning models. There are a lot of ways. We talk a lot about right sizing instances for compute, but any company that has deployed multiple machine learning models knows that managing the storage and the accessing of the features, which are essentially the variables in a machine learning model, oftentimes they're shared across models. You can either go the route of completely isolating them and duplicating, and that's not cost efficient. Feature store is essentially extremely performant in-memory feature store layer where you deposit your data there, and it can be accessed by multiple models and shared, and all of that sort of authorization that you would know and love. So again, two components that any machine learning organization that has deployed at least a single model has been moving towards, and excited to see those in the hands of folks that are using SageMaker now. But again, one of the big announcements here being Amazon SageMaker Clarify, which is announced as generally available today. Always exciting to see that. Did anyone else want to chime in? I feel like I'm monopolizing the time, so I'll pass the ball around the horn here.
Sure. So both data wrangling and managing a feature store, when I talk to customers that are super excited about machine learning and they've got the raw data, they know that there's a benefit on the other side, they don't quite grasp what they need to do in between. And one of the crucial yet probably unappreciated aspects of it are what you just covered. This whole data wrangling to get your data into a level of quality where you can actually use it to do good training. And then the feature stores, it's okay, what does this data really mean, and how do we take these raw elements and combine them in the right way so that we can train against them in a worthwhile way. They kind of intuitively know that there's going to be some level of cleanup involved, but they probably didn't understand, yes, this isn't optional, it's absolutely essential, it's more work. And I think one of the pieces that I picked up from this is the need for repeatability and consistency. When you're doing this multiple times, and you don't want to just have these one-off scripts and go through spreadsheets and just apply formulas to columns and so forth, you need to make sure that you're actually doing this in an engineering disciplined way, so that you can the next time you get a new set of training data, that you can apply the same steps to it, so that you're going to get high quality output from all of this work that you put into it.
Yeah, exactly. And, sort of first order of business when folks are working with machine learning models is obviously if you try to train and you have a data type mismatch, you'll get an error in your, from your training framework, right? It will literally stop you in your tracks. But a bit more of a difficult problem to grok is this notion of drift in data or bias in your data compared to, maybe another point in time, or certain assumptions that you make about your data when you go into using it for training with machine learning algorithm. And again, it's sort of silent error cases or silent faults here. So it's difficult to detect. But Amazon SageMaker Clarify, again, generally available today, helping to be able to conduct those bias and explainability tests after your training, to be able to detect some of these more silent, silent challenges that you may get with your machine learning error, again, which may not show up in an error, but hopefully with in SageMaker Clarify that sort of brings that to the forefront without needing to build up your own sort of internal observability system for it.
Some of what this speaks to it, and the way I see it, is that our customers are becoming mature and sophisticated in their use of machine learning, and they've gone far beyond simply saying, well, let's have some models and we'll throw some new data at it and just see what the inferences are. They're really saying we're doing this over time, and the results are so helpful and so valuable to us that we want to make sure that those initial results are good. We want to make sure that over time, if there's some drift, that we don't get surprised by what has happened. And the customers are asking us for this because they're putting this to use in important production systems. The customers wouldn't even necessarily know to make these requests unless these were genuine challenges they were facing. So this is to me a very interesting indication of where our customer base is with regard to actual production deployment of machine learning.
Yeah, and
yeah, that's totally right, Jeff. And speaking of maturity, I mean, two of the areas where we know that maturity is kind of driving this feature set that we build is in profiling and CI/CD pipelines. So with profiling, when you build traditional software, we've had decades of tooling behind us that allows us to see how a particular piece of software or service is performing in production. Where are the CPU cycles going? You have profilers that tell you all this stuff. And so another really exciting feature that we heard GA today is deep profiling for Sagemaker Debugger. And what this allows you to do is to understand and visualize the CPU, GPU, and I/O usage across the entire stack. So I thought that was a profound sign of kind of how mature and how and where these features are kind of being driven from, right? Like you said, Jeff, these are critical workloads now. Companies all over the world of every size and shape are depending on these kinds of workloads to derive unique business advantages, and these tools are kind of the next step for that.
Yeah, something that strikes me when I see that profiling is that we're at this very abstract level when we're doing our model building and our training, but the fundamentals still matter, right? Actually using your CPUs efficiently, using your GPUs as efficiently as possible, and understanding are you getting good value from the resources that you're paying for? And if not, can you use less resources, or can you use them more efficiently? Can you reapportion the way you're actually making use of them? So yes, it's the training is really abstract, but these kind of deep things that we were almost like kind of the things you learned really early on in your life as a developer, they actually still matter, which is to me always reassuring.
Oh gosh, you mean we can't just deal with arbitrary cloud compute units? We want to understand how our code operates? Oh, what a world to live in.
I know that we always want to think that way, but ultimately it actually does still come down to bits and bytes and how fast can you move data in and out of that CPU.
Physics still exists. The speed of light is still a constant, even with cloud computing. I wanted to geek out a little bit over this one to really give people a deeper appreciation for the ML AWS stack here. When you use through SageMaker, especially TensorFlow or PyTorch or MXNet, you can bring code that works with the exact same bindings, and we actually manage and operate hyper-optimized backend code for those given bindings. So if you take a TensorFlow workload and you run on your own machine and you run it on AWS, the same code will run more performatively because we have optimized it for the hardware infrastructure that it will run on under the hood. Now, this is actually not new at all. This has been around for years, but when we get lost in talking about some of these exciting new launches, we sometimes forget about it, or some folks are newer to ML here on AWS. So it's always nice to remind them. But to give a little more insight there for some of the folks that may have dealt with trying to profile on their own, I've run a multi-GPU rack to perform machine learning off of, and you'll find that between PyTorch, MXNet, and TensorFlow, the way that you have the ability and the tools that you could use to profile them are all wildly different. In some frameworks, the framework will just take control over all the memory on your GPU, and then it's sort of abstracted to you as to how you can allocate that or try and diagnose problems. In others, you may have more insight into that. And so, this is not simply a matter of making a job that was possible but tiresome easier. It's in many ways actually very, very difficult. You want to use a framework. You don't want to have to decompile how it was built to debug it in the way that you want. I don't think anyone wants that. That is why abstractions should exist in software, right? But it's challenging. And so deep profiling here is, to me, it signals AWS willing to take that that deep and hairy work and make it easier with a clean abstraction for customers, which, obviously we see changes, right? TensorFlow, immensely popular, still immensely popular, but PyTorch gaining a lot of popularity and becoming, number one in terms of utilization, I think. And so, these constants or things that seem constant in one day may change over time, but a service like deep profiling for Sagemaker Debugger, I would posit the guess that as additional frameworks become immensely popular, you can, continue to use that tool that you've invested in to get those same insights without having to learn whatever the framework du jour is.
Absolutely.
Anyway, that was a bit of a soapbox there on deep profiling, and it's hard, but an immensely valuable problem. I think the creme de la creme here from Sagemaker is we talk about it all the time. You don't get value from machine learning until you have an end-to-end pipeline existing. And what better launch than Amazon SageMaker pipelines, first announced in the Andy keynote. But to me, this is the bow that ties it all together, right? Data Wrangler and Feature Store. They're wonderful, and they fit into existing pipelines. And folks called them pipelines before SageMaker had a dedicated feature for it. But this really, in my opinion, is ties everything together.
It sure does. And once again, this speaks to what our customers are doing. And the customers are not testing and experimenting. They're using machine learning in ways that are actually their production scale. They're intrinsic to their business, and they need to treat their models as just another artifact that needs to be built and tested and deployed. And so seeing this as part of SageMaker just says, okay, we're at that point where people are doing this at scale and want to make sure that it's just part of their process.
Yeah, absolutely. Well, you know the saying, if data is the new oil, then SageMaker is your new pipeline.
Oh,
did Swami say that? I don't remember that quote from the slide.
No, I said it.
Oh, okay. All right, there we go.
But it's true, right? I mean, if you think about it, like crude oil. I mean, to take the analogy further, crude oil in its raw form is toxic. Nobody wants to store it. Nobody wants to handle it. And just like real data is, right? But if you look at for our other services, or other AI services like Macy, for example, right? We even have tools to help you kind of make best practices out of data storage and data sanitization. We have things that can automatically detect and remove PII. That's extremely important in a lot of different industry verticals. But then what you see here is, we see with Data Wrangler, kind of like cleaning that data, getting into all the right form and shape. We saw all the new features around Glue and all of our new data management features to kind of make that data easier to process from a variety of different services. And then later on, I also want to hear both of your opinions about all of the features we announced for integrating with our different data stores and integrating them more closely with ML, because that sounds very exciting as well.
Yeah, so I actually think that Matt Wood's demo really showed that in action. He said, we've got all this track and artist data. We'd like to build a recommendation service, really a really cool use case. And he showed we've got data in a bunch of different places. We've got some in S3, we've got some in DynamoDB. I think he said we've got some in Redshift as well. He spoke to how much work it takes to do the feature engineering on that, how to clean and combine the data. He actually said, let's combine the beats per minute and the genre into his new feature he called danceability, which sounded kind of subjective to me, but we'll let maybe it's actually not. And then he showed how we could actually deploy and manage all that with the CI/CD pipeline.
Exactly. Yeah. Again, truly end to end, right? You don't get value until your machine learning pipeline is serving inferences in a production application, or you're getting insights from the report. So seeing sort of how everything plugs in together is I think critical to visualizing what an initiative like this could look like at your organization. Unfortunately, I think we have about 5 minutes, gents. So we're gonna have to fly through some of these other launches. But in the same spirit of allowing end-to-end machine learning pipelines, we see the launch of Amazon SageMaker Edge Manager. Machine learning obviously has a lot of unique challenges and thorns, and doing that at the edge is even more difficult. Limited internet connectivity, low power, intermittent online ability sometimes, depending on if it's out in the field, what have you. But again, SageMaker now sort of taking the route of some of our IoT services and some of the offerings we've had there to enable sort of single pane of glass and easier fleet management for these machine learning models that run at the edge.
Yeah, and then real quick, just kind of covering some of the database integrations with machine learning that I mentioned earlier. We have a number of announcements here: Amazon Aurora ML, Athena ML, and Redshift ML, and then Neptune ML, not just to be inclusive of the graph databases here. But what all of these things have in common is the ability to kind of meet the customer where they are, right? We know that there are a lot of data engineers, a lot of data analysts out there who really kind of are more familiar with a particular data store with a particular set of trade-offs. And a lot of these capabilities, for example, are to do with enabling you to run a SQL query that invokes an ML service, and then having that data kind of right there available and integrated with all of your other SQL scripts and workflows. And then, of course, we have Amazon QuickSight ML Insights. And what this can do is kind of, this is really interesting because both QuickSight ML and QuickSight Q are kind of the integration of ML to kind of build higher order features. Jeff, I know you've looked at this stuff. You want to give us the quick 411 on this?
Yeah. So one of the things that I think this really solves is it's very easy to pull up one of these analytics tools and just keep changing things until you get a graph that says, okay, that's the answer I was looking for. And it's kind of cheating and reverse engineering the process. So using the ML insights to actually say, please explain to me how do we got to this result, I think is super, super important. And then the other way around, the QuickSight Q and saying, well, instead of trying to write queries and manipulate, let's just ask these questions. And in fact, as I was watching this, I thought it would be a pretty awesome thing to have for my social media and for my blog metrics, and be able to ask these questions about either or both of those. And would actually need to talk to my blog team and see how we can get metrics poured into Redshift so we can analyze them with QuickSight Q.
Yeah, it's very easy to forget how much we train ourselves to ask questions and how the machine will interpret it as opposed to how we would communicate with other humans. And another service and a set of launches that follow this trend of being able to meet people how they would query naturally is Amazon Kendra, again, our intelligent enterprise search service, with 2 new exciting launches. First being 40 plus new connectors for Atlassian Jira, GitLab, Slack, Box, essentially adding more data sources to be accessible through this humanly readable interface. And then additionally, incremental learning to improve the results and accuracy of those surfaced answers to the queries. So simply more data accessibility and doing so at a higher level of accuracy. And then next, I wanted to say Amazon Lookout for Metrics, extremely exciting, launching in preview a purpose-built service by which you can feed in any arbitrary time series data and be able to perform automated anomaly detection. Swami mentioned a large number of different metrics that you could use here, but this can be everything from sales to like number of visits to a site per day or impressions on advertisements. Ultimately, this time series data and being able to figure out anomalies both for positive and negative reasons, surfacing those in an automated fashion, immensely valuable to any business of large number of verticals. There's time series data in almost everything.
Yeah, so Matt briefly talked about the Panorama Appliance, which is super, super cool. I actually have one here in my office, but it's kind of hidden behind my green screen, and I'd have to step around that to find it. It's a super cool, really rugged device. You basically just set it up, you go through the console to get it configured, and you plug in your existing IP cameras to that. It's got pre-trained models in there, so you can use the pre-trained models. You can build and train your own models, deploy them to Panorama, and you can actually do inferencing at the edge with the video captured from your existing IP cameras, which I thought was really, really cool. And then you can use the SDK to build your own models and to deploy those out at the edge through Panorama as well.
Exactly. And we saw a large number of those industrial-oriented AI services in Andy's keynote. But the final unique launch here that we saw from Swami's keynote was the launch of Amazon HealthLake. And when you really break it down, this seems like a purpose-built, pointed solution to the end-to-end behaviors that we find that healthcare customers have been trying to build themselves. And there's a lot of unique challenges from compliance, data governance needs, redaction of PII, and the particular access patterns and ways in which data is queried. And so by talking deeply with these customers, combining both the technical needs with the use case patterns that customers are using, we see Amazon HealthLake here as a data management and access solution that helps customers get past some of those largest problems in that space. We saw a little bit from Elad Benjamin, GM of Radiology at Philips, who talks a little bit more about the need for such a service.
Yeah, and speaking of customers that are really moving quickly with all of the foundational solutions that we covered today, we have to call out Moderna.
Yeah.
I mean, Moderna, who hasn't heard of them at this point? They're a key player in providing vaccines for COVID-19. And Swami highlighted the fact that, or sorry, this is Matt that highlighted the fact that they accelerated their some of their processes for delivery within days instead of months. And when you consider what a critical role they play in helping us curb this pandemic, it's incredible, and it's an incredible opportunity that AWS has to kind of support these customers in their and their respective areas of and industries.
Exactly. We had on the tail end, again, none of this is possible without the education side of things, whether it's some of the foundations about machine learning or the ability to use many of the managed tools that we spoke about today. Obviously, a very important point to end on. Unfortunately, I can hear in my ear that we are at time. I wanted to say a big thank you to Jeff Barr for coming out here and helping us recap the ML keynote here in week 2 at AWS On Air. So, Jeff, thank you so much for that.
It's been my pleasure. Great to speak with both of you.
Awesome. Wonderful. Well, we have more content coming up right away here on AWS On Air. And if you're on the Twitch channel, stick around. I believe we have Containers from the Couch coming up next. So thank you again. Hang tight. And we have more content coming your way. Thanks again, everyone.
Bye-bye.
Hello and welcome back to AWS On Air, the official live streaming track here at reInvent 2020. We are back again with another session of Keynoteworthy, where all the faces you see here on the screen will be helping to digest all the exciting things we saw in the keynote this morning. This time, we're going to be talking about the global infrastructure keynote from Peter DeSantis. Before we get into things, I am joined by Rob, my co-host, and a very special guest in Jeff Barr. Gentlemen, thank you for taking the time. Excited to recap this with all of you.
Sure thing. Happy to be here.
Yeah, this is great. I'm just the opportunity to nerd out about all the really cool announcements and deep dives that Peter went into today. I usually don't like picking favorites, but this really was my favorite keynote to date. Just the amount and the topics that Peter dove into really hit home for me.
I'd have to agree, Rob. This really sets apart the difference between like a data center somewhere and something that's really not just been built, but rebuilt and iterated on well over a decade to build cloud data centers, and how special they are and how refined they are.
Yeah, there's a very particular quote that we hear all the time internally here at Amazon, but it is always great to see that posted publicly, and that is that there is no compression algorithm for experience. And I think there is no better example of that than some of these infrastructure keynotes that we've seen year over year. I love this keynote as well, and it's for slightly different reasons some of the other ones. It's that as an Amazonian, there's so much work that goes into these services, much of it sort of downstream, right, in authoring the services, but we get a peek under the hood here at what makes all of that possible, what makes availability zones, regions, networking, all of the bits that, even as folks building services at AWS, we want abstracted away. So always a great time. Now, Peter opened with a handful of topics that he would then cover throughout this keynote, and we'll try to touch on all of these. Those being, first, everything fails, so you should certainly expect that. Again, the quote that Werner has said time and time again, it's been on his shirt, I believe, or maybe that was Encrypt Everything. We talked a bit about custom silicon, so we'll get to that. Some really great strides in the sustainability space here with energy utilization and how we think about that here at AWS. And as always, some exciting customer stories. So in our 30 minutes here, we're going to try our best to plow through as much of that as possible. You think we can do it?
I think so. It's going to be a challenge. There's so much stuff that we want to cover, but these are really important topics. And just to kind of, the first thing that Peter mentioned on availability zones, I think there's something very interesting that happens here, because when we talk to customers about this, they all agree that availability zones and the architecture behind it is extremely important. It enables all sorts of synchronous replication architectures that really reduce the set of hard trade-offs that they have to make. But when you look at it, it's one of those things that in retrospect is obvious. Like, duh, why didn't we do this way? Of course it had to turn out this way, right? But as with so many groundbreaking inventions and innovations, that's actually not the case. If you were to rewind yourself, or hop in a time machine and go back, it was not obvious that this was the solution. And that's why I'm so glad that we have Jeff here, because you've been here for so long. You've seen the evolution of a lot of this stuff. What was it like from your point of view?
Well, it was actually great to be reminded by Peter that the first EC2 launched, and I remember very clearly writing that blog post, we did not have the concept of availability zones. It was a good reminder that we actually brought that in a little bit later. And so starting from there, and then Werner's been using that everything fails phrase for a really long time. I think it was actually everything fails all the time. It was great to actually get reminded of that. And then Peter spent a lot of time on things that were super, super low level. He talked about just getting electricity to the server, which you could always think, well, that's a pretty simple, straightforward thing. But he went through the generators and the switching and the UPSs and the workload. He talked about things like the complexities of having embedded software in all of these different pieces of equipment. If you don't own the software, the upgrade cycle can be very, very long. You can end up with features you don't really need because the vendors are building to satisfy a big audience. And really, I think talked about the value of owning these low-level components. He talked about generators, the fact that generators sit there idle most of the time. You need to be able to take a generator offline for maintenance, so then you need a second generator as the backup generator. And he talked about this great phrase, it was concurrent maintainability with redundancy. So lots of big words there, but really saying it's really important to be able to take one of these parallel components offline, maintain it, while you've got a hot spare there ready to go. And then a phrase that we use a lot at Amazon, and I actually did a little bit of research right before we started, blast radius. This idea if something does fail in some way, how much other stuff is affected. And it's good to hear that effectively every tech decision that we're making ultimately is one of the important factors is what is the actual blast radius?
Yeah, exactly. And, I think as developers, especially in more modern days, we understand deeply the idea of, dependencies, systems that are dependent on one another, or software services and microservices that are dependent on one another. But, under the hood, physical parts of a data center have their own dependencies, right? And so, maybe it's sort of out of sight, out of mind for a lot of developers. But one of the biggest benefits of using AWS and cloud computing is letting us have that part of the shared responsibility model, right? It's not just that we're going to run a data center, it's that we're going to think deeply about these problems and make sure that you're not just getting, a power line into your data center, but when we have an SLA and we can innovate to maintain that for you, that we really mean that. You're not just getting whatever the availability was when you first signed into the service. Oftentimes, we're continuously and iteratively improving this. But all of this to say, you don't want to ever manage more complexity than you stand to benefit from, right? With these interdependencies, or with smarter, more intelligent systems in certain regards, you have this sort of specificity. You have this trade-off, right? And Peter elaborated on this most particularly with the custom UPSs, I believe, or switches for power. And that's that when you buy commodity hardware or commodity anything, and oftentimes the provider is making a generalizable solution, but there are often trade-offs for having that be as maintainable as possible for you as an individual. And so seeing this innovation where at Amazon, we wanted to reduce that complexity. We built our own UPS or switches to be able to manage power in data centers globally and have sort of a layer of consistency regardless of where we were in the world. I always love seeing that because that's something I'll rarely get to read in a blog post from you, Jeff. But we see this on stage, and it just gives me a much greater respect for some of the innovation that's happening here.
Yeah, that's absolutely right. And one thing Peter touched on was the fact that this custom in-house switchgear combination with the uninterruptible power supplies has helped us achieve 7 nines of availability. Now that I know starts to sound abstract, but if you 7 nines of availability, do you know what that actually is? That's 3 seconds of downtime per year. 3 seconds. It took me longer to say the sentence than we allow for our power supplies to be down on average, right? So this is an incredibly highly available system. And so the joke goes with uptimes and numbers of nines. The story goes that there's a startup that's like, hey, how are we going to compete with AWS? They have 5 nines of availability. And then the startup's founder goes, oh, well, we're going to give them 6 8s, right? But really, I mean, it's so hard to emphasize because as you get up there, you have, in order to get that next 9, it's an order of magnitude improvement. And these are already razor thin levels of outage that are tolerable in these systems. But the other thing that we really talk about with these AZs is what they enable customers to do, right? And fundamentally, I'm really glad Peter touched on this, is that fundamentally by targeting the Goldilocks zone of between 100 microseconds to 1 millisecond of latency between our availability zones, we're able to achieve these sorts of synchronous replication architectures. Now, I know, again, that's a lot of technical multi-syllable words, but let's put this into context in a way that everybody can understand, right? You're trying to buy one of these new NVIDIA or AMD GPUs, and you can't get your hands on one. And you finally see it in stock. You click add to cart, and when you check out, it says, sorry, we can't check you out anymore. That's what happens when you have an eventually consistent system when you're trying to solve a problem like online shopping and you have a huge spike in demand for a limited supply. That creates a bad customer experience and you might lose that customer, right? And so what Peter is really saying is that by putting these tools into customers' hands, we enable customers to dramatically reduce the likelihood that a customer is going to hit that kind of disappointing user experience. And that's really, like, when we talk about the technology, it's easy to lose sight of the things that we're trying to enable with it. But I always want to bring us back to just what kinds of customer experiences we're trying to enable our customers to deliver.
Yeah, exactly. Eventual consistency and high latency are things that are tangible. You feel them when you use these applications, but I would say there's no more salient experience than the app being down entirely, right? And so when we're talking about ways in which we deploy our infrastructure or where we physically deploy it, the placement of these availability zones is not just important in terms of getting it close to the user, but avoiding things like natural disasters. The ability to, if you deploy within a region or within an AZ, to have full isolation from power lines, various threat vectors that could be applicable in a given region. And Peter said, firsthand, this is not, there's no single distance in terms of miles that works worldwide, because naturally so there's different threat vectors to having data centers be available all of the time, in different parts of the world. And so again, mating that latency Goldilocks zone with a mileage between data centers such that they are safe for high availability applications and synchronous replication, sort of this 1-2 punch, this balancing act between the two as we continuously expand our regions and AZs globally.
So Peter used this phrase, which I didn't quite follow. He said, the power to touch is the power to destroy. And I'm not quite sure if he was really saying we need to automate everything or be careful what you touch. I was actually doing live blogging while I was listening, so I might have missed his fuller explanation of that. But he talked about how we choose all these locations for AZs, and then we've got 24 regions and more in the works. And we've got the newest ones, Cape Town, South Africa, Milan, we've got Switzerland, we've got Indonesia, we've got Spain coming along. And in every one of these locations, we've got to make these really tough decisions of, okay, within this country, where's the natural location for multiple data centers, and what are the geographic conditions? What are he used that phrase, 100-year flood. What is the 100-year flood high water mark? Having to know that. Can we get power? Can we get network connectivity? Engineering a region and choosing the sites for the AZs in the region is a really big deal. And all this amazing engineering work and all this planning, maybe I'm just using one instance and I'm paying 1 cent an hour for this instance. I'm getting the actual benefit of all this, which I find really, really awesome.
Yeah, I think a really interesting image popped up in my mind when you were talking about how selective we are about where to build these regions and availability zones, because you're right. In every single place, the threats, the local conditions, they're different, right? And the fact that we're cognizant of those, the amount of care and attention. I almost want to see a TV show where Peter walks around to different sites, and then he like kind of goes, no, not here. That way, right? It would be, kind of she's like a Sherlock Holmes of infrastructure. I would watch that show. I don't know about you two, but that would be enormously entertaining to me.
This was not covered in this keynote, and I don't remember exactly where the canonical source of this was, shared publicly. But in terms of selectiveness and unique challenges and innovations, I know, for example, there was an instance in which we were expanding our infrastructure into a newer region that we had not been previously, and in this strange set of packet loss in our very early tests. Before any services were deployed there, we were trying to diagnose this. And it turns out that there was this very particular indigenous insect to that area that was able to dig into the ground and eat through whatever this like otherwise industrial and highly rated cabling that was used in most other parts of the world. And as a result of that, AWS actually built, using custom materials science, a new cable that would work and be optimal for that region. So when we're talking about the depth of this innovation, it is literally down to not just we talk about the silicon and the chips, which we'll get to in a little bit, but even into the cabling and how it goes into the ground in certain instances. So it never ceases to amaze me when I hear certain stories like this.
That's not on my list of like top 100 favorite snacks. So to each their own.
Yeah. Well, we're definitely going to revisit this topic of regional expansion, because this is the expansion itself is extremely impressive. But as we were expanding, even in this unprecedented year full of unique challenges, we were able to do so while staying ahead of the curve on some of our climate pledge commitments. So we're going to revisit that at the end. But now I want to switch over to talking about the strides we've made in AWS Custom Silicon. And this kind of begins with Peter's overview of the AWS Nitro system. The Nitro system is custom silicon from Annapurna Labs. We started working with them all the way back in 2014, and then we eventually acquired them. And since then, they've been a key enabler for EC2 and then so much more, right? He kind of showed us a real quick tour of how Nitro, the latest version of Nitro, was enabling these Mac OS instances. And this is unprecedented. I am still trying to wrap my head around the fact that we have macOS support on EC2. Jeff, Nick, what do you guys think?
I'm blown away by it as well. And I had a ton of fun putting that blog post together, I think, as we talked about last time. And it was really cool. He just said, okay, we opened up the Mac Mini and we put the Nitro card in there and connected to the Thunderbolt port, and away we went. And I know the customer response has been pretty amazing. It's been something people have been asking for a really long time. So it's the speed that we're innovating with Nitro is, I think, kind of blowing me away, what we're able to do there.
Yeah, one of the really exciting callouts with Nitro here, especially with the the new Mac OS EC2 instances, is that one of the fundamental differences between the Nitro system and I believe like Zen from years prior is that with this new implementation with Nitro, you don't have to have computational overhead on the device that is running this, such that when you get a Mac Mini with these specs, you don't have to worry about how much overhead the AWS management various systems that can be working are taking away from that, such that you would even consider going and getting a Mac Mini and racking it on your own wall and handling all of that upkeep. You can really deeply understand and trust now that the performance that you see there in the spec sheet is exactly what you're going to be able to get. And we see that story sort of extended even further, not just with the Nitro system, but with other advances in the Graviton 2 chips. So, when we're talking about low latency, low jitter, again, Peter talked at length about how difficult of a challenge this is to sort of get both of these right simultaneously. But the combination of sort of building everything or deeply integrating through deep vertical integration here, both the silicon and the chips in the Graviton 2 processor and the Nitro system at the hypervisor plus and beyond level is, I believe it was a 50% improvement of internal latency and jitter from the C5N instances, which were again x86 with Nitro 3, to the C6Ns, which were powered by the Graviton 2 chip and the Nitro 4. So immense value for what is simply to customers a new generation of instances where they can, in most scenarios, just with the flip of a switch, access all those performance gains. No massive re-architecting of their applications. It quite literally happens, automatically in a lot of scenarios.
So going from the general purpose hardware, things like Nitro, and we'll talk about the Graviton 2 really soon, the Inferentia, such an amazing development. This idea that it's going to reduce the cost of inference by up to 45%. And that's really cool all by itself. It's powering some really cool custom use cases. It's powering Alexa voice recognition. But to go from great idea to fabricated silicon to actually having it in the cloud and available to customers so quickly, if you wanted to get something like that for your own data center, where would you start? And how many months would it take for you to convince someone that you needed those? And how would you experiment with them to really be confident that those were the right thing to solve your problem? That you can just use them when you need them is a huge advantage to the cloud that I always like to reiterate. The fact that great idea, try it out on the hardware in the cloud. You don't have to wait for hardware refresh cycles. You don't have to wait for approvals and room in your data center. Just launch what you need and try it out.
Yeah, I mean months. I mean, I don't think even months is realistic, Jeff. I think the fair bet, if you want custom silicon, is years, right? Because just think about the expertise you need in-house in order to design and develop these things. And then if you kind of think about it as an investor, like, what is the ROI on this? Is this really what makes your business special, right? Developing custom hardware to speed up inference for your machine learning models? If it's not, you really have to think about how much time and energy you're willing to invest in that in order to eke out incremental gains and in order to stay competitive as technology in the landscape changes, right? These are not trivial challenges. And if your core business value proposition is not that, you really have to think hard about what that is, what it is that you're doing, right? You mentioned Graviton 2. I'm going to spoil the reveal here. I mean, this is just an incredible announcement. Graviton 2 powering a bunch of what we call 6th generation EC2 instances across the board, whether it be networking, general purpose compute, high performance, multi-core, you name it, and we have it. Now, one thing I want to call out right at the top is that Graviton 2 is an ARM-based processor. Which means that when you run software on it, it has to be compiled to run on ARM. Now, this used to be a problem, but in the years since ARM has become so prevalent with mobile devices, with embedded chips, with more and more ARM workloads running on the server, you'll now find, I think you'll be pleasantly surprised if you could take a look at your workload. Let's say it's a database, for example, with Postgres, or let's say it's with Node.js or with Go. Almost every major workload that you can find has ARM support natively. So when we talk about moving from x86 to ARM, this is really not the kind of blocker that it used to be. And I really don't want you to get hung up on that, which means that we can now actually compare apples to apples when we say Graviton 2 provides, some level of improvement in terms of performance and efficiency. And boy, those are some pretty significant improvements. Nick, Jeff, you want to take it away?
Yeah, I think your point that ARM support in the tool chains and the apps is there and it's mature is really important. That customers are moving from x86 to ARM in hours and days. It's not a gigantic re-engineering of what they do and getting all of this great benefit. To me, a lot of this is the fact that we have this incredibly good understanding of workloads. And Peter talked a lot about scale out computing. He talked about this idea that doing serverless and using lots and lots of cores with many threads, that today's OSs are finally really good at managing a multitude of cores and scheduling threads onto them really efficiently. And also you think about using microservices in production. We look at all those things, we can see what our customers are doing and what they're asking for and say, okay, we can build custom silicon that is finely tuned to being able to run those workloads as fast and efficiently as possible. He talked about lack of variability of performance because we're not doing the hyper threading, for example, so that we're not using the core for two different threads and worrying about the variability there. He talked about lack of variability of power management, which modern chips have a really complicated set of steps up and down where they're trying to eke out as much performance by regulating the power to the chip. Wonderful features, but they also make it really hard for you to know what level of performance you can expect.
Yeah, precisely. And in some of these x86 architectures, some of it becomes a little bit of a black box, right? At the point where the end developer only has the choice to really scale up or scale out if their application is designed to be able to do such. And so just seeing AWS innovate so deeply at this level on behalf of customers, not because customers demanded it, but because we have a mutually aligned value to make their workloads run more effectively, more performantly. And one thing I want to call out, and we'll get to it in a more broad sense in a second, is actually just the energy efficiency. It's wonderful. We'd love to be able to talk about the fact that we can run workloads quicker and cheaper for customers, and directly translate that to dollars and cents. But the Graviton 2 chip is inherently the most is more energy efficient than any other chip that we have ever run on consumer grade or on any of the EC2 instances that we've offered. So this really just is a win-win across the board, right? And one final thing on Graviton 2, before I'll hand it off to everyone else, was the migration to Graviton 2 or to ARM-based architectures is not all or nothing, right? If you have an application that has multiple different services or microservices, some of those may have an easier time, lifting and shifting, or just simply, toggling on the ARM, an ARM-based instance. You don't have to wait until your entire application can be migrated. You can do it sort of piecemeal and start accessing those cost savings with whatever parts of your application can have the quickest wins there.
Really good point. All right, well, we talked a little bit about power. Why don't we dive deeper into climate pledge and power and sustainability?
Yeah, that's great. That's a great segue. I mean, so we mentioned earlier that we have continued our pace of rapid regional expansion. And by the way, regional expansion also includes some of our edge locations as well, right? I think when we talk about regions, we usually focus on these, our main regions where a lot of our compute power is centralized. But in fact, if you look at some of the posts that we release in the announcements, it's actually also accompanied with an expansion of the Amazon Global Network, which is the network that powers the regional expansions. But what I find amazing is that we've done all of this as step in step with our climate pledge. Now, a quick recap of our climate pledge. This is a goal to reach net carbon zero by 2040, which is 10 years ahead of the Paris Agreement. And many other companies have joined this pledge. And as Amazon, we've set up a $2 billion fund to invest in low carbon projects. And not only that, we've made sure that a lot of our regional expansions are as efficient and as green as possible. And really, it was incredible to see the pace of progress, even in this unprecedented year of challenges.
Certainly. There were a few ways that if we really break down how to achieve net carbon zero or reductions in carbon emissions, there are three main strategies that Peter talked to. The first was the greenest energy being the energy we don't use. So anywhere where we can simply be more efficient, that's obviously great and eliminate some of that waste. The second is the use of renewable energy, obviously renewable energy being low to no carbon, depending on the application to it. And the third being reduction of indirect emissions. And we'll sort of go through each of the three of these here. First, when Peter talked about UPSs and some of the hairy bits of making power highly available and having redundant systems and all of that, by diving deep and really having a well-oiled, deeply vertically integrated system, you can actually eliminate a lot of waste in just transformation of power along the way. So examples here being when AC power changes to DC and back again, you lose some percentage of that signal just to heat. And so by being able to have these custom power systems, we're able to regain 35% of that lost energy that otherwise existed in the system. Next up, we were also able to see that AWS data centers are 88% more carbon reduced than an equivalent enterprise data center. And this is for a lot of reasons. Much of this is simply being able to right size the utilization of those resources, right? We are very meticulous about how we plan these expansions. We don't want to have resources sitting around, but because this is the name of the game for AWS, we've gotten very good at being able to right size and do that capacity planning in an extremely efficient way. But, again, next up being renewable energy. Does anyone else here want to talk a little bit about that one?
Yeah, I was blown away by the numbers that Peter shared. He said that before 2019, we had a little over a gigawatt of wind and solar power in the US. This year, we've apparently brought on about 3.4 gigawatts of new capacity, including both solar and wind farms in China. And that we're now at about 6.5 gigawatts of renewable power globally. And he said that we've done the largest amount of renewable energy expansion of any company in the space of a year, which is just really impressive. And I think it's easy to sign up to any kind of a long-term commitment, but actually delivering real numbers against that is really impressive.
Yeah, I agree 100%. And what's really interesting to me about problems like these, where we're trying to reduce carbon footprint, these are big, thorny problems that face local challenges, different kinds of regulatory challenges, because we're operating globally, right? And so really, like the amount and the complexity of this problem cannot be overstated. And in fact, we've still made such large strides that, relatively speaking, other problems start to seem larger by comparison as we start to chip away the major pieces of it, right? The energy usage, the cooling usage, the water usage. In fact, Peter mentioned the need to now look at how we can reduce the peripheral emissions from our partners and our contractors, for example, right? For example, he alluded to the fact that cement and steel production each account for 8% of worldwide carbon emissions. And specifically in the case of cement, and we use both of these materials a lot in building data centers. And when we work with our partners now, and this is one of the ways that we're applying our Climate Pledge Fund, is to take a look at innovative ways to reduce carbon emissions in the manufacturing process for cement or cementitious products. That was a word of the day for me, cementitious. I'm going to try to use that.
Definitely a word for me as well.
Yeah.
Cement and cement accessories at a certain cartoon.
Cement accessories, exactly. But this is right. One of the things that blew my mind, I really have to look this up, is he talked about ways to kind of bake the CO2 directly into the cement, which not only reduces the weight and the density of the cement, but also makes it more resilient while locking in that CO2 and making sure that it doesn't get emitted into the atmosphere. It's just such a cool way to take a look at this problem, and it's so important now.
Exactly. We love to see that innovation really at every part of the emissions, supply chain in a way, right? It's a complicated problem that requires nuanced and pointed solutions all across the board. Last thing I'll call out before we are just about at time, Rob, again, you mentioned the $2 billion fund for accelerating these sustainability efforts. When we talk about cooling, for example, oftentimes that comes from various water supplies and sources. And again, globally, that presents unique geographic problems. And Peter called out a large number of unique ways in which we're reinvesting in watershed restoration projects in Brazil, for example, revitalization of water sources, or even amelioration of certain parts of, I believe, Cape Town, where their water sources could be affected by a new and invasive species of insect, right? So really, really excited to see this investment in the local communities where these data centers are being built in a way that, we think about our customers, obviously, but, where we exist and operate these data centers, the people there are, and their well-being and the sustainability of all of this is extremely important to us. So unfortunately, we are at about time here. We have another exciting session coming up immediately after this. But again, this was Keynoteworthy. Joining me again, Jeff Barr and Rob Zhu, talking a little bit about the infrastructure keynote from Peter DeSantis. Gentlemen, thank you again for all the help. For everyone who's tuning in from home, stick around. We have more content coming up right after this. We'll see you back again here at 8 p.m., though, for a full weekly recap. So thanks, everyone. Stick around. We'll see you soon.
Bye-bye.